All right, I just started a live streaming to YouTube too. Um, if we ever get more than 20, I think 20 or 25, I cannot remember which one, people watching it live streaming on Discord, then the additional people will have to watch it through YouTube. I don't think we'll hit that limit. I got 33 people responding to the time preference, and about 46% of those people preferred this particular time slot, which is the majority. So I'm only expecting about maybe 17 to 18 people, watching the class live through Discord. And you should be able to see the live stream of my browser, which is currently on Canvas right now in student view. If you cannot see it, you'll probably be using a web client, a browser client. It's probably better to download the desktop client and run it on the desktop computer. The mobile client will see the live stream too, but the screen will be quite small unless you have a tablet. And we got about 2 minutes before we start. I'm just gonna pre-share with you what we'll be doing today. I'll be going over the syllabus kind of quickly because I don't want to spend too much time to talk about the syllabus. So I will only point out the really important parts of the syllabus. And then we'll move on to the first topic. Is there a question? Okay. So if you're not speaking, it is usually better to... Okay, go ahead, Julian. Okay, if you're not talking, it is usually better to turn off your mic unless you are sitting in a relatively quiet environment, and it's okay to leave your mic on. Just looking at the time, we got 1 minute left. So I am going to open up the syllabus. This is the student view of Canvas, which means you should see something kind of like this, obviously, except for reset student and leave student view, because that's just a feature of Canvas that allows me to see what you will be seeing. Because otherwise, sometimes I would hide items and not realize that certain items are invisible because I have hidden those particular items. So I am going to open up the syllabus right now, which is just a PDF, and you are welcome to download it, print it out, put it into your folder somewhere on Google Drive. Some students ask me for syllabus after a semester ends because when they are transferring, sometimes it is helpful to have that available. And I just realized that I have a typo here. It is not micro computers, it is micro computers. So let me see. I think I got enough time to fix it. Maybe not, because it's already 9 o'clock, so I'll fix it later. All right. Well, welcome to the class. We got about, I would say, close to 20 people on Discord. So you guys are all watching this live streaming through Discord. And I really encourage people to kind of keep this as a routine, because structure is important when we are taking classes or doing anything online. If you have any questions, you can ask questions either through the text channel, and I want you guys to use the text channel that is day specific, which is 20200608 for today. So this way, all the conversations, through text, it will be recorded for people who cannot make it to the live session. Some people cannot make it because they have to work. Some people are taking some other classes where they are physically required to be somewhere else. So, not everybody can make it to the live session. So I'm going to go over the syllabus really quick at this point. So this is the syllabus. I know it is long for a syllabus, but it's long for a reason. So I'm just going to scroll through some of these items, especially the more important ones. Class meeting time, this part, we already know. The office hour for this class is from noon to 1, which is right after the lab session. So I hope that is convenient for most people. The learning objectives here, I'm not gonna spend too much. Go ahead. Hi, Dan.
Good morning.
Good morning. So Dan is our is the instruction assistant, our IA for this class. So yeah, go ahead, Dan.
Oh, no, sorry. I'm just listening.
Okay. All right. So you might want. Yep. Thank you, Dan. All right. So there we go. So we're moving on. So my name is Tack. Okay. You can call me Tack. You can call me Doctor Tack. You can call me Professor Tack. You know, they're all fine. Last name is Aoyong. It's really kind of difficult to pronounce because we got like 5 vowels kind of strung together. So just call me Tack. That's perfectly okay. The phone number is not really that useful because we have got Discord. Okay, so who needs a phone when we have Discord? If you need to call me at the phone because you only have a landline at a time or something like that, that's fine too. Whatever message you leave on the answerer is going to be emailed to me as an MP3 file. And it's going to be sent to the account that is right below the phone number. So this is my official school account email address. But for an online class like what we're having right now, I'm just going to use Discord for most forms of communication, because I think Discord does a much better job compared to email or most other um, medium, for communication, uh, even compared to Zoom. Okay, I prefer Discord to Zoom. So the presentation delivery method is kind of interesting. Okay, normally I only teach classes, face to face, but this is an online class. Okay, so we still have reading material. I'll show you guys where to find the reading material. I'm starting to record video clips that are not live. In other words, in the lab, you will find there are video clips that will show you how to do a particular thing. So that's also a part of the delivery method. The synchronous mode is what you're experiencing right now. I'm here, you're here. Um, we can interact in real time. For people who are watching this, in a recorded form, that is called asynchronous mode. And then we have interactive activities, and that's basically your lab. This part is actually wrong. I don't have that server running anymore, so I'm gonna have to update that as well. Regular effective contact policy, it has to do with how often I check my email and how I respond to people. Obviously, when you are in the live session or the synchronous session like right now, I can answer your question right away. Okay. Otherwise, the turnaround time can be up to a day. So try to utilize the live sessions, as much as possible. And over the weekend, the turnaround time can be up to 2 days. So that's basically what the time frame policy is talking about. Conduct policy is really kind of important, even for online classes. We don't want unintentional distracting behavior because we just want to make sure that the environment is effective for learning and teaching. So, distracting behavior can lead to an environment that is not easy to learn from. Okay, but the good thing is we are online, right? I mean, if you turn off your mic, you can be eating, fried chicken or popcorn for all I know, and it doesn't interfere with the teaching of the class at all. That cannot not happen in the classroom, and Dan knows that we have a really strict policy that we do not let people drink or eat in our classrooms or labs. So this class being online, if you want to, type with greasy fingers after eating fried chicken on the keyboard, hey, that's okay too. So that's kind of cool. 7.2, so these are much more serious stuff. Intentional behaviors that can cause confusion, fear, intimidation, or discomfort, or anything that is either by itself dangerous or endangers other people. So all of those are basically big no-nos. Um, First day of class. You're here right now, so you're good. But I still need you to put some entries into the daily log in order to basically say that you're here in class today. So you can just type right now that you're reading the syllabus as I'm talking about it. Okay, that's fine. Accommodations, if anyone needs accommodations, you need to contact the DSPS office. You can call them and let them know that you need their service. I don't know exactly how they offer service at this point, but this is the office to call if you need any one of these services. For example, if you need interpreters, if you need a tutor, note taker, readers, test facilitators, adapter computers, and so on, call the DSPS office. Yes, we are going through the syllabus right now. But don't type it here. Type it in your daily log document, which is already shared with you, like I think yesterday sometime. Okay, absences. Okay, this is a big topic. Yeah, no problem. Um, I'm responding to the text. So section 10 is really important because I still quote unquote take attendance, and the district has an excessive absence policy of any absences 6% or more is considered excessive. So I want to answer Martin's question first, okay, on the text channel. What format do you want us to type into the daily log? Put our name first. That is not necessary because the document is shared with you only, so I know exactly who has which document. So you can just type in whatever you want. You can take screenshots, paste it in. Just do it however you want to do it. Okay, there's no set format. This is the content of that document is for you and you only. I only need the timestamp for attendance purposes. So I only care about timestamp. Okay, the content is entirely up to you. So I hope that answered Martin's question. So continuing on with excessive absences. So with online classes, I would basically use activities online to see whether people have been quote unquote absent. So for each day that I have planned synchronous sessions, I would basically check to see if people have been participating. And the way I check whether people have been participating is through the daily log. All right. So if the daily log shows that someone has not put in any entry on the entire day where I have planned a synchronous session, then I will count it as an absent. Okay, but it doesn't have to be during the time when we have a live session. Okay, so for people who are watching the video, as long as it is done in the day, so for today, it is as long as it is before midnight of the 9th, it's fine. Okay, well, I do have to specify it's Pacific Daylight Saving Time because otherwise somebody might say, but in Hawaiian time is not the next day yet. So it is in PDT, okay, Pacific Daylight Saving Time. So that's basically how I take roll, and people can miss up to 2 days and it is still not considered excessive. The third day is excessive. So that is really important to remember. For the most part, for online classes, it is a little bit easier to quote unquote attend, or it's harder not to attend or miss a class because there's no commuting. Okay, a flat tire would not impact taking a class online if you already have a computer at home and you have reasonable internet connection at home. So um, so section 11 talks about what absences are excused, and then section 11.1 talks about what excuses are unexcused. So basically everything that is not due to the sickness of the student, or it is a summon by the government, is not going to be considered excused. Late policy is also really simple. There's no late policy. No late work is admitted, or it just simply won't be graded. Or Canvas would basically just not let people turn in anything after the due date. So that's about it. Okay. If you are sick and you cannot get things done, you have to let me know, and then we'll use the sickness excuse, to basically give you more time. But you need to have some proof that you have been sick. Then we got 13. Section 13 is also really important. That's one of the things that I really do have to talk about, because we are doing stuff online, and my experience in the spring has been some people are looking at this as open season for doing stuff that is not exactly honest. Okay. I spotted quite a few cases, and in some cases, people kind of confessed right away and apologized, and in some other cases, people just simply refuse to acknowledge or refuse to admit. But I do have solid proof. So the one thing that is really important is if I spot anything like this, if I spot any academic dishonesty, and I have really solid proof, okay, then I will first ask the people involved and let them know that I got evidence of that stuff happening. And I would also be informing the associate vice president of student conduct. Okay, so that's going to be done regardless. Okay, um, and I already talked to the AVP, the associate vice president of student conduct. So basically, for people who are um, the first time, doing this, and it's not a very severe case. Okay, so it's not involving a ring of many people. Typically, it's not going to be the consequence is not going to be very big. Okay, that people involved, in a particular incident, will not get any points of the activities involved. So if it's only one question in a test, then the entire test is not going to get any points. Okay, but beyond that, it's not going to. There won't be a lot of extra consequences. There won't be. Usually, it doesn't result in expulsion or suspension or anything like that. There will be a letter coming from the student conduct office, but it's just usually a warning. And occasionally, the students involved will need to write a response to that letter acknowledging the importance of academic integrity. But if it is a repeated case, if somebody is, for instance, if it is like the 10th time, okay, somebody has been doing this since they enrolled at ARC, then obviously the consequences will be far more severe. All right, so I just want to point this out because it has been happening a little bit more often since we transitioned to online modality. So I just want to point that out, that this is still important to me, and I will be checking. So this is section 14 is important too. Just click on this document. I hope the document is still correct in terms of the link. Yep, it is still correct. Okay, that's good. So let me switch back to the syllabus. Oh, nope, 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 that's the wrong one. Okay, there we go. So this is a really important document. It specifies, what your rights are, which means, if you feel that someone, like myself, okay, if I ever accuse someone wrongfully, this document will tell that person what, that person can do. How to file a grievance and so on. So it is a very important document for you guys to read as well. Section 15, talks about classroom behavior expectation. So chatting is kind of an interesting one because you guys can be chatting using direct message on Discord or on your phone by texting all you want, and it does not interfere with other students. Okay, so as long as it doesn't interfere with the class in general and it does not interfere with other students, It's okay. Okay, so this is actually one of the great things of um, taking an online class is you don't have to be sitting still or not chatting with other people. If it does not interfere with your learning and the learning of the other person, it doesn't matter. Interrupting is also not going to be an issue, as long as you let me finish my sentence before you ask a question through the voice channel, or you can just type in the text channel anytime you want to, because I can keep an eye on the text channel and only respond when it's a good time to respond to it. But I guarantee you that I will respond to it unless I totally missed it. Okay, then you can just go ahead and kind of let me know that I missed it. Um, there's no need to turn off your mobile devices. In fact, some of you may be using a mobile device right now to watch the live session. Okay, so that's all kind of be a little bit different. Okay, because when I wrote this syllabus, it was written mostly for face-to-face classes. So there we go. Keep going. Okay, section 16 talks about how to attend lectures. Okay, particularly the live sessions, or if you even if you're just watching a recorded session, it still applies. Okay, so one thing that is different about this class is I record everything. So from your perspective, there's no need to jot down notes, okay, to copy whatever you see on the screen, because it is being live streamed to YouTube, and I have on the side, which you cannot see, a window on YouTube, so I know that is still going. I can double check to make sure that is still going. Um, Although the voice part, yeah, the voice part should be done as well, because I'm checking my voice meter and it's still working for OBS, which feeds to YouTube. So you don't have to copy everything onto your notes, okay? But what is going to be important is to locate the video recording, the time of the time when I start to talk about a particular topic. So you might want to index that. For instance, okay, when I start to talk about transistors, okay, which I hope we'll be able to get to today, okay, so you can write down in your notes, okay, on the side on a piece of paper, or you can utilize the daily log document that I gave you guys. So you can use that to write down at time mark 9:19 in the morning, tech starts to talk about transistors. Okay, so that is your own index. Okay, if you ever need to get back to that discussion of transistors, you can quickly locate it, because it's going to be about 19 minutes past the beginning of the recording. So keeping that catalog or index into specific content of a particular day is going to be really helpful to you when you need to review some of the content. All right, so moving on. So section 17 is really long. I'm not going to go through that. The gist of section 17 is this class is never about memorizing stuff. Okay, it's all about understanding concepts and being able to problem solve using those concepts. That really is the focus of not only this class, basically all the classes that I teach, have that particular focus. So now the question is, what do you mean by understanding the concepts? Okay, let me answer the question from Zachary. You need to sign in to apps.losreels.edu to access the daily log. It is being shared to you through the Los Reels apps.losreels.edu resource. Yeah, there we go. Okay, continuing. So a really important part of succeeding in this class is knowing whether you understand a concept or not. Okay, and that's why we got the lab activities. A lot of the lab activities are designed so that you have to do something, you have to problem solve a little bit of a problem, but unless you actually understand the concept, you wouldn't be able to do it. So it's really kind of a quick check of whether you understand the concepts or not. So section 17 is really long. I'm not going to go through that, and I will leave it up to you to read it. Okay. And we are moving on to grading. Okay, so grading is interesting for this class. Okay, so this is the context of A, B, C, D, F. Okay, that's a typical GPA type of categorization. And the short description, I think most people understand that part because that's explained in just about every transcript. Okay, they explain what is an A, what is a B, what is a C, and so on. And I basically, also explain in terms of how I score, what would get, what kind of answer would get an A, what kind of answer would get a B, C, D, and F. Okay. I also related to job evaluation, product evaluation, like from Amazon and so on. And the last row is the most interesting one, is at the end of the semester. Okay, once we add up all the points, all the scores, and everything, how do I decide the GPA, or not GPA, but how do I decide the letter grade of a particular student? If it is exceeding, excuse me, if it's at least 87.5%, is an A. If it's between 62.5% and 87.5%, is a B. If it is at least 37.5%, is a C. Okay, so the way I break down the ABCDF letter grades is different from other classes, and that's because when I grade homework assignments, the first exam, the second exam, and the final exam, I use exactly the same standard for grading those answers. Okay, I would assign full points to an excellent question and to an excellent answer. I will give 75% of the points to a good answer, 50% of the points to a C answer, 25% to a D answer, and 0% to a F answer. And because I do this consistently across all the assessments, and that's why at the end of the semester, I can just use exactly this kind of percentage range to convert the score into a letter grade. Okay, so I'm just going to pause a little bit here and see if people have any questions. All right, no questions so far. So the activities that I use for grading in this class, we got graded assignments. Okay, so all the labs are quote unquote graded assignments. If you cannot finish a lab, quote unquote lab, during the lab time, it's okay. Okay, I typically give people until at least the next day to turn it in. So you're not under a lot of pressure to get it done in 1 hour and 20 minutes. Okay, you actually get about a whole day minus maybe 2 hours to get it done. So all of the graded assignments, okay, all of the assignments they can do on your own, they only account for 20% of the final grade. And then the other 80% will come from exams. We have the first exam that is scheduled at about 1/3 through the class. So we got 4 times 8, which is 32 meetings. So in our 10th meeting or so, we'll have our first exam. In our 20th meetings or so, we'll have our second exam. And then the final exam is on the last day of this class. So that's going to be our final exam. The first exam and the second exam, each one will contribute 20%, and then the final exam on its own is going to contribute 40% of your grade. So do we have any questions about how the grade, how the scores break down for this class? Okay, no questions. All right. Moving on to section 19.2. Occasionally, especially when people remind me to do so, I'll give you ungraded assignments, okay? Which means they are still activities, they're problems to solve, but they do not count for any points for grading purposes. So why does anyone want to do this? Because these ungraded assignments will still help you understand the concepts. It will still give you a chance to practice hands-on, okay, to kind of further understand the concepts, or at least to test whether you understand the concepts or not. So with ungraded assignments, I won't be grading it. There's nothing to turn in, but I will talk about the solutions. And when I talk about the solution or the answers, you might want to double check and compare my solution to your solution. If they are the same or they are comparable, then it goes like, okay, well, that works, cool. If they are different, okay, then you might want to look at the differences and see whether they are different enough that one is correct and one is incorrect. Now, if you have questions like, I can see my solution and your solution are different, but are they equivalent? I cannot determine whether they are equivalent or not. You can ask those questions, and I will help you understand whether they are equivalent or not. So that's that. And then the last part of the syllabus is a tentative schedule. It needs to be here, but most often I would deviate from these things. Okay, so in other words, for the most part, actually, it's going to be presented in a slightly different order, but all of these topics will be covered at some point. Okay, they just won't be following exactly the same order here. All right, so I think this is the end of the discussion of the syllabus. As I will be presenting it, you still need to go through and read the entire thing. Okay, so because it's an agreement, for you to continue to take this class is that you have read the syllabus, you understand the syllabus, and so do we have any questions about the syllabus? All right. All right, so if there are no questions about the syllabus, I'm gonna close this tab, and we will officially start our first topic in this class. All right, so all the reading material that relates to this class are already on Canvas. I did not put a time lock of any kind on the content, so that means you can read ahead of me as much as you want to. Okay, and I will just follow the order in this in the modules. So the first one is physical states, truth, numbers, and computers. The next one is testing a circuit. Now these two are mostly just kind of FYI, okay, but it is still useful to kind of read these topics in the order that they're presented. This is your lab for today. Okay, this is an activity that you can do today, and the due date is already listed here. Okay, so the Logisim setup due date is tomorrow at 9 a.m. So that means you can be working on this until and turn in everything up to 8:59 tomorrow in the morning. Okay, I do not suggest or recommend people to push it all the way right before the due date, but you can technically turn it in right before 9 a.m. tomorrow. Okay, so that's up to you guys to decide how you want to do it. But the rest, okay, such as values, numbers and bases, binary number addition, binary number subtraction, blah blah blah, okay, these are all links to topics that you can read. This is quote unquote the textbook. Okay, I don't have a printed textbook for this class. Everything that you are going to read is linked from Canvas. Now there is a supplemental text. There's no need to buy it. Okay, this is only for people who kind of feel better when they have additional textbooks. So you can go ahead and get the supplemental text, which I think you can get for free as a PDF. But if you get it, I would recommend people to pay the author. Okay, I think he's only asking for like $10 or something like that. So but nonetheless, it is totally supplemental. Okay, it is not required. All right, so we're going to move on to the first topic of today, and it is about physical states, truth, numbers, and computers. You can open up the PDF if you want to. You can also open up the HTML version. And this is one thing you can do also, okay, depending on what operating system you're running and what kind of programs you like to use. you can, if you want to, download the PDF, then you can use a program like Xournal, Xournal. Okay, so let me kind of point you to that website, Xournal. Oh, okay, no, there we go. Xournal, there we go. So Xournal is kind of interesting. It's open sourced, which means it is free. It's free to download. It can open up PDF, okay, just like Acrobat Reader. So what is so cool about it? Well, Xournal allows you to write notes on top of PDFs, and it's free. Okay, I know you can do this for with a lot of other applications, but this one is free. So if you're like me and you have a tablet PC that has a stylus, this allows you to jot down notes next to in the same PDF. So this way, you can when you're reading the material, you can kind of jot down questions like I'm not really quite sure what tag means by floating point. Okay, so you can kind of jot down. So when I go over that topic, then you can ask questions, and if you still have questions at that time. Or during the lecture, I talk about something, I presented an example, then you can kind of add to the note and say that, oh, okay, at time mark, blah, 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 tag presented an example that illustrates this particular concept. So you can mark up the PDF any way you want to, either using handwriting, you can type in content, you can draw pictures and whatnot using, Xournal, and it's free. It is available for all platforms. So you can download it and install it in Linux, in Mac OS 10, and also in Windows. I find it to be really useful, and this is also what I will be using in this class when I need to kind of hand draw stuff to illustrate ideas and concepts. So that is an extra resource for you guys to use. So getting back to module 0280, okay, so we'll go ahead and start to talk about physical states. So when we talk about physical states, we're talking about physical states like whether a circuit is completing or not. We're talking about whether there's light or not, or whether there is an electrical potential that can be measured or not. Okay, so we'll start to talk about physical devices first. Okay, in other words, what devices do we use in order to make computers? Section 2.1.1 talks about electromechanical devices. Electromechanical devices, as the name implies, uses electricity in order to turn something, okay, in order to move something. And by turning and moving something, in return, it also changes, how electrical connections are made. So it is kind of a feedback thing. Okay, we use this electricity to turn into mechanical movement, and then the mechanical movement in return would alter the state of electrical connections. So the best example I can use to illustrate a electromechanical device is a relay. Okay, so if you want to know what a relay is or what it looks like, just go ahead and look up a relay. Okay, and you might want to add electrical, and you can also look up electrical relay. Okay, and I think there are videos that can show you exactly how it works. Okay, so you can look up some of these videos. Okay, I haven't watched this one before, but it has a electromagnet. Okay, and this is a spring, and so the spring normally would open the circuit. In other words, these two contact points are not touching. But when you complete this circuit here, this is the symbol of a battery. So when you complete this circuit, there will be current flowing through the wires that is wound around a ferrous core, which will then result in a magnetic field. The magnetic field will then attract this point here, which is also ferrous, which means it responds to magnetic attraction. So that will pull the contact lever down, and then therefore completing the circuit, because the two contact points will complete. That will basically in return complete the circuit. Then whatever load you have here is going to get the power source, which in this example is 222 volts. Okay, so that's basically an illustration, a quick illustration of an electromechanical device. The electrode part comes from the contact here to complete the circuit to the electromagnet, and also refer to completing the circuit to turn on something here. The mechanical part comes from the lever that is actually just mechanical. Okay, normally it is open because of the spring, and it closes because of the magnetic field. So this is a good example of an electromechanical device. So we can, in fact, make computers using just electromechanical devices. The only problem is with electromechanical devices, the computer is going to be pretty slow, because how long does it take to close a circuit in the relay? It's going to be measured in at least multiple milliseconds, if not longer. So multiple milliseconds, which is multiple thousands of a second, does not sound like a lot of time to us. But when you compare that to how fast a computer, an electronic computer, can operate today, it is really, really slow. Because we are measuring clock speed at gigahertz today, with AMD processors, which has, I think, the smallest process up to this point. We can clock a processor easily at 3 gigahertz. So that means we can complete 3 billion cycles per second. With a relay, okay, let's just use an example. Let's say this is a super fast relay. So, to complete the circuit, it only takes 1 millisecond. It can only have 500 cycles per second. Then you guys will be asking, but you said that thousands of a second, right? Shouldn't we have 1,000 cycles per second? No, because to close it is 1 millisecond. To open it is another millisecond. So one complete cycle is going to take 2 milliseconds. So that means we can only have 500 cycles per second. So when you compare 500 cycles per second to 3 billion cycles per second, that is a big difference. Okay, huge difference there. Now, electromechanical devices are actually what people used at the end of World War II. So for those people who want to kind of get a really good idea of, what does it look like, how does it work, and so on and so forth, if you watch the movie An Imitation Game, that movie actually shows, what an electromechanical computer looks like. And that device in that movie was actually used to decipher messages that were encrypted by the Enigma machines that the German used at the end and in World War II. So it's an interesting movie to watch. Even if you just want to understand what a electromechanical computer looks like. So after electromechanical devices, we got vacuum tubes. Okay, and if you click on this hyperlink here, it will bring you to Wikipedia. So Wikipedia has a pretty good explanation of what a vacuum tube is. It shows you how it works. Okay, so if I scroll to this page here, okay, there we go. It kind of shows you how it works. For the most part, we are interested in a triode at least, because a triode is basically a switch where, one electrical signal is used to switch another electrical signal. But the way it works, okay, let me see if I can open the image in the second page here. There we go. Okay, so this is a much larger image of it. So inside the vacuum tube is a heater. Okay, this is a filament. It is used to heat up the inside of a vacuum tube. And the reason why we need that heat is because electrons is not readily going to leave a metallic surface unless the metallic surface is hot. So that is why we have a heater here. And then the heater is heating up what we call the cathode. The cathode is the source of free electrons. In other words, it's basically a metallic surface that is heated up, and electrons are basically ready to leave because because inside the vacuum tube, guess what, is a vacuum. Okay, there's no air. So with the absence of air, and a heated metallic surface, electrons are actually ready to leave. Okay, just give it a reason and it's gonna go. And what is right next to it is a grid. Okay, so the grid can have its own charge, which means it can be positively charged or negatively charged. Typically, it is positively charged, and because electrons are negatively charged. So if the grid has a positive charge and the cathode is negatively charged, then the electrons has a pretty good reason to leave the surface of the metallic, surface, and it will pass through the grid and be collected by the anode. So the anode is what is going to collect the electrons. So if I go back to vacuum tube, so the full explanation is actually done here. Actually, I may be incorrect that the anode is the one that is positively charged, and then the grid is what is collecting the electron that's trying to get to the anode, but it got collected by the grid. So I think that is the case. So I explained it incorrectly before. But anyway, it is basically a switch because we can control whether there's a current passing from the cathode to the grid by controlling whether there's a positive charge at the anode or not. Okay, so it's basically a switch. So getting back to the notes here. So the idea of a vacuum tube is we basically have a switch, or if you want to look at it as a valve, that works too. Now, what is important about these valves is you're using the same physical quantity to control the flow of the same physical quantity. You're using you're using the flow of electricity to control the flow of electricity. Okay, that is an essential requirement for a device to work in a computer. Now, does that mean that if you have a device that can be controlled by the flow of water, but what it controls is also the flow of water, can you use those devices to implement a computer? The answer is, interestingly, yes. You can, in fact, do it that way too. And this is also why some people in Minecraft, okay, they design computers and logic gates and whatnot using redstones. Okay, so if you have played Minecraft before, you might want to dig this up. Okay, you just look up, I think it's redstone, if I remember correctly. I haven't played Minecraft for a long time. Redstone Minecraft logic gates. Yep, there we go. Got its own wiki page. There we go. And this is actually a very interesting way to learn logic gates, which is kind of what you can do on the side. I'm not going to use Minecraft to teach logic gates, but for those of you who know how to set up redstone gates already in Minecraft, this may not be a bad way to do it. Okay, because if you have more pathways to do the same thing, then you have more pathways in your brain to understand the same thing, and then you can apply what you have learned a little bit more flexibly. Okay, so the bottom line is there are different ways to implement logic gates, but the key is whatever physics you use to perform the controlling part has to be the same quantity that is being controlled. Okay, that is a basic requirement. So we're moving on to section 2.1.3, which talks about transistors. So transistors are interesting because they are still in use today. I think people started to use transistors at the maybe at the tail end of the 50s or the early part of 60s. Okay, that's when people started to use transistors. So all the previous technologies like electromechanical devices and also vacuum tubes did not last very long. Okay, people used it for a while and then they go like, well, this is way too slow, okay, or this is way too power hungry, and so on, and they stopped using it. But when they got to transistors, we have been staying with transistors for 60 years, um, or a little more than that. Okay, so transistors is still being used today. Okay, the big difference between transistors from the 60s in those computers, in the mainframe computers, and the transistors that you find in the latest AMD processor is the size. Okay, because before they were discrete components, which means you can actually use your fingers to pick up a component code and look like it and go like, wow, this is one transistor. Now transistors are small, really small, as in like 7 nanometers wide, which is really small. Okay, because if you think about the cross section of a human hair, you can fit, if I remember correctly, you can fit at least 100 transistors across a single strand of human hair. That is how small transistors have become. Okay, but nonetheless, they're still transistors. So the next section talks about physical states. Okay, so physical state is basically something that you can measure using some sort of instrument. Okay, so for instance, if you're talking about the flow of water, okay, you can put a pedal into the stream of water and watch it turn, right? So you can actually determine whether water is flowing or not. If you want to know whether there's an electrical potential, okay, otherwise known as quote unquote voltage on a conductor, you can use a multimeter, right? So you can use a multimeter and measure compared to the ground level, okay, is there a voltage? Is it positive? Is it negative? How positive is it? And so on. So those are all physical states. Um, I hope there are no questions so far, and I don't see any questions from the text channel. So I'm going to continue the discussion here. And then in section 3, we talk about truth. Okay, so truth in this case has nothing to do with the truth of nature. In other words, we are not talking about physical science. We are talking about truth as in logic. Okay, so because in logic, we have true and false as basic values. Do we have a question? Nope. Okay. All right. So whoever has the sign-in name of JAS underscore G17, you got two things to do. You have to change your nickname on this server to your actual name. And then two is you might want to kind of mute your mic unless you are ready to talk. Okay, so moving on. So now we talk about transistors. Okay, now this part is starting to become really important because this is actually what your lab is going to do. So what your lab is going to do is to build a logic gate using transistors. This is what a N transistor looks like, in Logisim, and this is what a P transistor looks like in Logisim. So when you compare the two, the only real difference is one has a bubble and then the other one does not have a bubble. Okay, now you might say, but the direction of the arrow is different. Yes, that is true as well. However, the direction can be changed. In other words, you can change the orientation of a transistor to kind of change the arrow so they align the same way. So the only real difference is whether it has a bubble over here or there's no bubble over here. Let me turn off my alarm here. Sorry about that. Talking about distractions, I'm the one who's distracting the class. Okay, so there's an N transistor, there's a P transistor. The actual physics behind how a transistor works is not really important, okay? But what we do want to understand is what is a transistor? It is a valve, okay? So when we look at a transistor, it is a valve, and this is not a bad time to introduce Logisim. There's instruction in the lab already, where to download Logisim and how to run it. So when you run Logisim, this is what you will see. So I'm just going to put it into the area where it is going to be recorded. Okay, so in Logisim, you can go to wiring, okay, and this is where you can pick up a transistor. So you just single click, okay, this is a single click, And after you click on the transistor, you just have to move your mouse pointer to the main area of Logisim, and wherever you click, okay, is going to be where the transistor is going to land. Okay, this is not a drag and drop. So once again, I repeat, this is not a drag and drop. This is a click and then a click. Okay, let me just explain it one more time. Click here, click here. So this is a transistor. Now in Logisim, it is really kind of important to pay attention to the property pane of whatever you have selected. So now that we have selected a transistor, this is an instance of a transistor. You can see how it has two types, okay? Because when you click on type, you can select between a P versus an N type. You can also see, okay, let me click it again. You can also change the facing. This is how you change the orientation. You can rotate, using facing, you can rotate a particular component. If I rotate it south, that's going to go from east to south, which means it is going to rotate clockwise 90 degrees, like that. Okay. You can also flip the left and right. In other words, if you want the arrow to go down, but you want this connection to appear on the other side, you can go to gate location and then flip it. So that flips just the gate location. And the number of data bits is going to be 1 for the experiment that we're doing, so don't change that. Okay. All right. So now that we know how to put a transistor and how to control the properties of a transistor in Logisim, it still hasn't answered the question of what does it do, right? So to answer that particular question, it's one really good resource is to go to the help menu of Logisim. So you go to help, you click on, if you want a quick tutorial of how to use Logisim, click on tutorial. If you want to get a general guide of how to use Logisim, you can go to user's guide. They're both written fairly completely and helpful, so you might want to give that a try. But if you want to find out how a particular kind of component works, then you go to library reference. So you click on that, it opens up a smaller window, and you can see how the libraries are organized exactly the same way as in the tool or component selection pane in Logisim. Okay, so you go to wiring library, click on it, and you can find transistor. So you click on transistor, and now you can see the explanation of the behavior of a transistor. So I'm just going to go through this truth table here. So when you look at this truth table, the source is wherever the arrow is coming from, and then the gate is the pin that is either connected to a bubble or not connected to a bubble. And then the value that you're seeing in the table has to do with what we call the drain. So this is the drain here. So what this truth table is telling you is if the source is high, 1 is high and 0 is low. So if the source is high and also the gate is high, then the drain is also going to experience high. Then what is Z? Z is basically saying it is not connected. Okay, it means the drain is not connected to high nor low. Okay, so if this is a little bit confusing, which I would not be surprised, okay, let me draw a picture. So I'm gonna use Zernal to draw a picture. If you have a PC that has a stylus, this is actually a really great tool for taking notes and drawing pictures and whatnot. I don't know how it compares to OneNote or something like that, but since this is free, it runs in Linux, which I do use, which I'm using right now. So this is the tool that I use. All right, so let me draw a picture first, okay? And oops, okay, I need to fix something first because the the stylus is not there we go. So now it should be good. Let me undo this first. There we go. All right, so let's look at a. It is still not doing what I think it should be doing. Give me one more second. I think I know why. Give me a second because I have to change the screen resolution on my computer. There we go. Okay. So we give it one more try. Yep. Okay, so this time it's working. Great. All right, so this is a p-type transistor. There's a bubble here, and there's an arrow. Now, the arrow is very important because without the arrow, we cannot tell which end is the source and which end is the drain. The arrow is always going from source to drain. And this part is the gate. So remember what we talked about a little bit earlier when we talked about the syllabus? This may be a good time to kind of mark the time when I start to talk about a transistor in an interactive way. Okay. All right. So now the question is, what does it do, with a transistor? So what I can do is I can give you another truth table, okay, or another way to explain it. When gate and source are the same, then the drain, okay, so it is drain is not connected to source. Okay. And when we say when gate differs from source, then drain connects to source. All right, so this applies to both the P and the N type transistors. Okay, so this applies to for both P and N type transistors. This applies. Okay. All right. So then, what is the big difference between the P and the N type? The big difference is for P-type transistor. Okay, for the P-type transistor, source connects to 1 or the high voltage. And you probably guess what the N-type transistor does, or how to connect an N-type transistor. Source connects to 0 or the lower voltage. So that is the difference between the two types of transistors, is how do you connect the source. The drain is kind of like the switched end of a switch or valve. The gate is the control of the valve. The source is basically where the flow is coming from. With a P-type transistor, the source is the positive voltage. In other words, we're controlling whether the positive voltage, quote unquote, the source, connects to the switched end, which is the drain. With an N-type transistor, we are connecting the source to the low voltage. So we are basically controlling whether the low voltage flows to the drain or not. Okay, so let me see if there are any questions, because this is where questions can be expected. I'm not seeing any questions. All right. So now let's take a look at a circuit. Okay. This is basically this is 1 or high higher voltage. We are not talking about hundreds of volts. We're talking about multiple volts at the most. Okay, so we'll take a look at a circuit like this. So we have two p-type transistors here. The flow has to go in this direction because it has to go from high voltage. This is where the source is, right? So the source has to connect to high voltage for a p-type transistor, and we know these two are p-type transistors because of the bubble. Okay, so now we connect it to two other transistors. So these are two additional transistors, and this is ground. Ground, you can see it as 0 or low voltage. All right. So you can also see how these are n-type transistors. So the source is going from low voltage to high voltage. Do we have any questions about this diagram at this point? I'm gonna give you guys a few seconds to ask questions.
Does every circuit have to have the ground in it?
Only when we use transistors. So this is the only class, this is the only time when we actually use transistors. After today, we'll not use individual transistors. We'll start to use logic gates, and with logic gates, we do not have power and ground. They are implicitly connected, but they're not explicitly connected like this. That's a good
Okay.
question. Very good. Any other questions? All right. There are no additional questions. All right. So what we'll do is we'll start to connect the gates. Okay, so we have this input pin. So input pins in logic sim are always squares. So we have one pin connected to here, but the same pin also connects to the other transistor. And we can also name these transistors. I will call this one Q1. Oh, okay. Okay, so this is Q1, Q2, Q3, and this is Q4. So we can see how the gates of Q1 and Q3 are interconnected. And then we can also connect the other two together. Okay. And this is what I do when I'm using hand-drawn, circuits, is I use this bridge to basically mean that these two wires are not connected. So if I go back here, this wire is not connected to this wire. One is flying over the other one. But when you see a dot, that means they are in fact connected. Okay, so now we have two input pins, and we're gonna have one output pin, and I should be consistent and use the fly over symbol here. So this is an output pin. We can call this X, we can call this Y, and we'll call this, I'm tempted to use Z, but I don't want to do it. Let's call this just output. Okay, there we go. All right, so now the question is, what if X is 0? Okay, I just want you guys to help me figure out what if X is 0 and Y is also 0. Okay, so with this particular scenario, I want you guys to tell me whether a transistor is connecting the source to the drain or not. Okay, so that's what we want to find out. So we're going to say Q1, Q2, Q3, Q4. Okay, and we just want to know whether each transistor is connecting the source to the drain based on what we showed a little bit earlier, which is the picture right on top of this. Okay, so we'll focus on one transistor at a time. Let's look at Q1 first. Okay, so we want to look at Q1, and then we ask, is Q1 going to connect the source to the drain? So can someone remind me, what determines whether a transistor is connecting source to drain or not? It has to do with the gate, right? So it has to be the relationship between the source and the gate. So when does a transistor connect the source to the drain based on the relationship between the source and the drain?
The source and the gate have to be different signals.
Yes, exactly. Okay, so if the source and the drain excuse me, if the source and the gate are different, then the source will connect to the drain. Okay, that's what we talked about a little bit earlier. So in this case, for Q1, you can see the source is always connected to 1, but X is a 0. So that means the gate and the source are different. So that means Q1 is on, which means it is connecting. It's connecting the source to drain. So we'll say, yep, source connects to drain. What about Q2? Same situation, because with Q2, the source is always connected to a 1. The gate is connected to Y, but Y is a 0. 1 is different from 0. So for Q2, it is also on. Source connects to drain. What about Q3 and Q4? Let's check it out. Well, let's check out Q4 first. Q4 has the source connected to ground. Wait, hold on a second here, Tack. With Q1 and Q2, we look at the top connection to see where the source, how the source is connected. How come with Q4 we look at the bottom connection to see how where the source is connected to? Can somebody answer that question? It has to do with the notation of a transistor. What is the arrow indicating? The arrow indicates which end is the source and which end is the drain. The source always goes to the drain, so the arrow always points from source to drain. Okay, that is why this connection point here is the source of Q4. Okay, so now we have to compare the source of Q4 to the gate of Q4. The gate of Q4 connects to Y. Y is a 0. So Y and the source of Q4, or I should say the gate of Q4 and the source of Q4 are both zeros, which means we are not connecting source to drain with Q4. So I'm going to show it as Q, S, D, but there's nothing connecting those two. Q3 is kind of the same thing. Q3 is kind of interesting because if the drain of Q4 is not connected to ground, it doesn't really matter what Q3 wants to do because the circuit cannot be completed because one of the two switches is off already. But even if Q3 has its source connected to ground or to 0, the gate of Q3 is still connected to 0 because X is 0 as well. So that means with Q3, the source and the drain are also not connected. Do we have any questions about this picture up to this point? Because this is kind of a analysis of a circuit based on what we have described the behavior of a transistor would do. Do we have any questions? I'll give you guys a few seconds to ask questions because this is kind of important. All right. I saw somebody typing a little bit earlier, but I didn't see anything coming out of the text channel. All right. So based on this configuration, how is the output connected? Okay, I got one question right now. So I'm going to wait until Alfred is done typing. Okay, somebody asked a question in general. That would not be a good place to ask questions. Alright, so I'm going to go to the channel. Okay, so people who have been posting over at the general channel, you need to kind of copy all that stuff to the date specific, text channel. But I'm going to read those questions here too. What is the triangle on top? The triangle on top, which is this part here, that's the positive voltage supply. We see it as 1, basically. This is the quote-unquote source of 1. And then the ground, which is this symbol over here, is the source of 0. So I hope that answered the question. And let me switch back to the other channel. Okay, so thank you, Alfred, for pointing out that the question was asked in a general text channel. All right, cool, excellent. All right, so now it is confusing. Yes, it's a little bit confusing, but so you have to understand the rules that dictates the behavior of a transistor. When the source and the gate are the same, then the drain does not connect to the source. When the source is different from the gate, then the source connects to the drain. And then with a p-type transistor, the source always have to connect to 1. And then with an n-type transistor, the source always has to connect to 0. So those are the ground rules of how transistors behave. I'm just reading the text here to make sure that I'm catching all the questions. I'm gonna wait a little bit because Martin is typing. You can use the voice channel to ask questions too. All right, so the question is, so the gate and source are both applied to the same voltage source, then the source is not connected to the drain. Okay, so it's opposite. So if I go back to, oh, darn it, just switch to, okay, let me switch back here. So if I go back to the earlier slide here, for both the P and the N type transistors, when the gate and source are the same, the drain is not connected to the source. When the gate is different from the source, then the drain connects to the source. Now, that's only one part of the rules. The other part of the rule is if you have a p-type transistor, which means there's a bubble here, then the source should connect to a high voltage, or 1 in our schematic. When you have an n-type transistor, which means there's an absence of a bubble here, then the source has to connect to the low voltage, which we know as 0. Is that okay? Does that work, Martin? Okay, I think Thin is typing right now, so I'm gonna wait for his question. Okay, so Martin says yes, and Thin is typing. I'm waiting a little bit for the question. Okay, so the question is about Q3. If Q4 is not connected, then we assume Q3 is 0. So Q3 is not connected because regardless of what the gate is, Q3 is not being able to reach 0 because Q4 already opens the circuit. But it is also not connecting. All right. So basically, we say that Q3 is also off. It is not completing a circuit. All right. So with this diagram so far, okay, if I want to know, what the output is connected to, can somebody do an analysis and figure out how the output is connected? Particularly, I just need to know, is the output connected to power, or 1, or is it connected to ground, which is also known as 0? So we start with the output here. I'm going to use a different color. In fact, I'm going to use a highlighter, which I will undo a little bit later. So I start with the output, which is here, and I go to here, and then ask a question, which way is connected? In other words, can I go through Q2 to go to 1? What do you guys think? If we use the table down here, where is the output connected? Can I connect to the one through Q2? What is the state of Q2? Yes, okay, very good. So because Q2 is connecting, so this is one path that the electrical signal can go. But wait, there's more. If I go all the way here, can I go through Q1 to also go to 1? The answer is, once again, yes. So this is also connected. Cool. But I want to be sure, okay? Can I also go from here to ground? Is there a way to get to ground? Well, the answer is no, because Q3 is not connecting. Q4 is also not connecting. So there's no way for the output pin to connect to ground. So that means at this point, the output is going to measure 1. Okay, it's going to have a state of 1, which is basically just high voltage because it connects to the positive voltage source. Is that okay? Does everybody kind of understand this part? If it doesn't sink in the first time, you kind of have to watch this maybe a second time, but the really important part is to go back to this part here, okay, which basically sets up, how do transistors behave. Okay, but this is really just a quick summary of the other document that we looked at a little bit earlier. And I need to go back to that document here. So this is basically just another way to explain exactly the same thing. So when the source, okay, so if we just kind of focus on the p-type transistor, if the source is a 0, then the drain is either a 0 or it is open. It does not connect to anything. If the source connects to a 1, which is the higher voltage, then the drain connects to the source, but only if the gate is a 0. So you can see how the source and the gate have to be different in order for the drain, which is the value that we see in the table, to connect to the source. Now, the Z, it means it's not connected. So that means even if the source is hardwired to the positive voltage, but if the gate has the same voltage as the source, then the drain is going to be not connected to anything. Okay, it's simply not connected. So that's how we read this table. Do we have any questions about how the table that I'm pointing out right here is really a more formal version of what I wrote here? I hope so. Okay. All right, so we are about 5 seconds away, no, 45 seconds away from the end of the lecture time. So I do want to double check and make sure that people do not have any questions up to this point. And it does not look that way. Okay, so let me just kind of point out what we are going to do next. We're going to take a 10-minute break. Okay, so you guys can go get something to drink, eat something, and then come back, hopefully. And then what we'll do next is to do the lab. So when you go back to Canvas and just kind of scroll down a little bit, this is your lab. Okay, this is the Logisim setup lab, which has several questions, and then there's a place for you to turn in a file. These two links in between, which is a zip file that you can download, and also how to test a circuit, they are kind of optional. You do not need to click on these in order to do the lab, but they will give you some context information of why this lab is important, because the way you turn in the file in the lab is to allow me to test the circuit that you're turning in, and these two links here explains how I test your circuit, what you turn in. So we got a question from Zachary. How do we know which of the reading needs to be done every day? Do we need to read the whole module? Will I tell you? So basically with so this is where we are at this point. We are reading physical states, truth, numbers, and computers. So if you can read ahead of me by about a module, by about a link, that's good. So that means on by tomorrow, okay, if you have read this entire thing, it'll be helpful. If you can read slightly ahead, that's even better. Okay, so that means if you can start to read values, numbers, and bases sometime before tomorrow, okay, that will be good. So basically, you just have to kind of read where we are currently at, and then read a little bit up to maybe one link ahead of the lecture. So that would be ideal. Okay, now if you don't read one link ahead of the class, it doesn't mean that it's going to be really bad. It simply means that you won't be as prepared as people who have read one link ahead. And because this is the first day of class, nobody is ahead of anyone else, because this is kind of the first time that we got into Canvas. The labs are always kind of be interleaved. In other words, when we are done talking about values, numbers, and bases, you can expect labs to appear in between these two links here. So the labs are interleaved with the topics, but they're always kind of in a certain sequential order. So I hope that answers Zachary's question. All right. If they're okay, so we got some more. Yep. Okay. Great. So once again, these two links are not 100% necessary, but it gives you the background information of why we are doing the lab. Okay. So let's go ahead and take a short break. I'll be back by 10:30. So at 10:30, okay, this is just kind of the quote-unquote the structure time for you guys to start to do the lab. But basically, you'll be doing the lab on your own, on your computer, okay, using Canvas. But I'll be around to answer questions if somebody has a question. And then we can utilize Discord. So if you have a screen that you want to share with me and go, okay, please, can you take a look at this screen? Blah, blah, blah. I have a question related to this. I can use Discord to look at your screen. So I'm going to stop the live stream kind of like in the next few seconds, because I got one direct message, and let me see if that's related to the whole class. Oh, the access code. The access code is just Logisim. Sorry about that. So when you get to the lab and when you click on take the quiz, it will ask you about the access code. The access code is just Logisim, all in lowercase. So it's LOGISIM, all lowercase. And then when you click submit, it will open up the quiz. Well, it's a quiz, but it's actually a lab, because you have until tomorrow 9 a.m. to complete the whole thing. So I hope that answers the question that I got from direct message. All right, cool. So I will just type it here too. Okay, the access code to the lab. Oops. Is just Logisim, all lowercase. The time limit for the quiz is until tomorrow at 9. And you can take the quiz as many times as you want. It will count the highest score. Yep, no problem. All right, so I'm gonna get off of, I will stop live streaming now, and then I'll get off of the voice channel. I'll go get some water to drink, and I'll be back at 10:30 in case any